Period. All right. Period. Yes. All right. Ready? Here we go. When I'm setting these up, it wants us to find the P of the incenter, right? When they say incenter, what they mean is there's a circle inside of this, right, that we're going to find. And inside that center is the center of the circle, which is going to be P. All right? And there's a lot of cool things that happen when you can create that. Okay? You have to know the rule. How are we going to create the incenter? And to create the incenter, we're going to do what's called angle bisectors. So we're cutting the angles in half. Right? Cutting the angles in half. So our first step, right, is what letters are they? A, B, C, X, Y, Z. So A, is that right? B and C, X,
no.
Y and Z. No?
A, C, B. You got X, Y, Z right.
Man, whoever wrote this test is weird. Oh, it was me. That is true. Okay, so A, B, C, X, Y. That is weird. Why is Z between A and B? That makes no sense. Okay, anyway, what are these points? These are going to be where the circle touches or becomes a tangent. This tangent line becomes very important. Later on in calculus, we talk about tangent lines a lot. Okay? We're going to start talking about tangents and stuff. Now, tangents, remember when we talked about adjacent angles that are next to angles? Tangent lines are lines that touch a curve at one point. Okay? And so that's what's going to happen here. We're going to create this circle inside here. So this circle is going to be a perfect circle, right? I don't know. That doesn't look too perfect. But it's getting there. Let's make it more round. There we go. How's that? A little better? A little worse? Alright, we're getting there. Alright, there's a circle. That's pretty good, right? And the center of that circle is going to be in here somewhere. I'm going to show you how to find that center. It's actually pretty easy. If we have a straight edge. Can I find a straight edge? Oh, here's one. Alright, so I'm going to take this, right? And I'm going to cut this angle in half. Okay? So my first step is to take angle A, right? And cut it in half. Okay? And I'm also going to do angle C, B, and C, and I'm going to cut all of those in half by doing what's called the definition of an angle bisector. Right? So all we're doing is cutting the angles in half. And when we do that, when we follow this line out, say this line, cut this line in half, that looks like about half. And we follow that line straight, it'll lead us to the promised land, or at least, kind of, to the center of the circle. Okay? So then I cut this line in half. It'd probably be better if I used an actual straight edge rather than that. I'm erasing my board. Here we go. So then I'm going to come down, cut this center in half. Boom. Okay, and then I'm going to cut this guy in half. And all you got to do is cut each angle in half. Once you cut those angles in half, they're going to produce a center. Okay? Okay? Rewrite this. Sorry about that. Okay, and they're touching right at this point X, right at this point Y, and right at this point Z. And those are very important points, okay? Because what happens is, think about a circle. What do we call a line segment that goes from the center of the circle to the outside of the circle? What is that line segment called? We usually define it by the letter R. 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 In a circle. R stands for radius. There we go. So the step 2 is finding the radii, because there's multiple radius. You can't say radiuses, so you have to say radii. Okay? So the radius becomes radii plural. I don't know if that's spelled with 2 I's or not. I'm not a good speller. So, but radii, I would spell with 1 or 2 I's. I don't know. I should look it up, but I'm not gonna. Alright, so those radii are P, right, is that point in the middle. So P, Z, P, Y, oops, sorry, P, Y, and P, X, correct? That is our new radii. So we created them by what? The definition, oh sorry, that was step 1, that's step 2. And that's the definition of what? A circle, or the radius of a circle, okay? Okay, so the radius of a circle is how we come up with that definition, right? So, since we hit the point, now here's the cool thing about what this Incenter does, okay? The cool thing about this Incenter, I mean, if you can be a math nerd and be cool, like me, yeah, okay? So, the coolest thing, I guess you could say, about this Incenter is it creates these radii, but the radii are specific. And the radii are perpendicular to the tangent line. Okay? So remember, we created the tangent line. The tangent line is a line that touches a curve at exactly 1 point. Da 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 da. Right? So this radius, PZ, now we can say, okay, PZ is perpendicular to what? What segment? PZ. Perpendicular to what segment? What? Say it. Believe in yourself. Say it. AP. There you go. Power to the ladies. AB. Come on, men. Step up. Yeah, I'm talking to you. Alright. Or boys. Whatever.
Why don't you step up?
You're almost going to be men. I'm trying to step up.
Why
It
didn't
hurts
you answer
though.
either?
Alright, next. PZ. What's another one? PZ and PY is perpendicular to what? What's PY perpendicular to? Come on, what's that segment? Believe in yourself, people. Believe in yourself. PY is perpendicular to what is this segment? CB. CB. Or BC. I don't care. A lot of times people like to write them in alphabetical order. If you want to write CB, cool. If you want to write BC, cool. Alright? There's one more. What is it? P what? Come on. They have them on every military base. P. What's the other letter we didn't do? Z, Y, and PX is, a lot of you aren't military brats, obviously. All right, so the PX, right, is perpendicular to what? What segment has X on it? Come on! It's the last segment. AC. Does everyone see that? Is that kind of viewable? A little bit? That this is perpendicular to this. This is perpendicular to that. This is perpendicular to that. Why? And that's where we're learning about incenter. Definition of incenter. Very powerful. Okay? Now, what did we just create? Uh-oh. 90-degree angles. So, guess what? You're going to see this a lot more in the next chapter. Okay? When we talk about tangent, cosine, sine. Or SOHCAHTOA. Right? People used to make that like a native reference. Very racist. Right? SOHCAHTOA. Right? So they're like, okay, white man. So, but it was just their way of trying to get you to remember it. It's just an acronym for sine, cosine, and tangent. Okay? We'll talk about that next chapter. It's a big thing. Alright, what's next? So we said we're going to get the angle bisector. We're going to create the circle. Then we're going to substitute the numbers that they want us to put in, right? So, we found the incenter. We have all this power, that's 4. Number 5. We're going to continue. So this was for 4, okay? But we're going to use 4 to do 5. Does that make sense?
What?
We're going to use 4 to be able to do problem 5, okay? So now we're going to plug in, it says here, that the measure of XCP. So X, the measure of XCP is equal to 36. Okay? So XCP, where is XCP? XCP. So that means this measure right here is 36. Cool? Alright. What else? It says BAC is 25. So the measure of BAC, the angle BAC, is 35. Okay? And this is given, right? And this is step 4. Okay? Okay, step 4. And it's given. And that is BAC. Where is BAC? BAC. Oh, dang. Is this whole piece, right? That whole piece is how much? 25 degrees, right? Okay. Now, we know everything in this dang thing. You didn't even know it, do you? We can know so much, it's ridiculous. Let's go over some of the easy things we know. Okay? We're just going to list them. Step 5, some of the things we know and why. Yes, sir. 36, oh, how did I get 36 and 25? Good question. Thank you. So, first they told us that XCP was 36. Is that the same on your guys' test?
No. 26.
Uh-oh. Oh, I'm doing the test. Don't look at that! My bad. So, it says 26? Did I hand out the wrong one to people? This should be not the test. I should be handing out the practice test. So some of you who got this just now have the test and not the practice test. Anyone have the test? There you go. Anyone else have the test who just took it from me today?
Oh, shit.
Anyone? We're good? All right, thank you, sir. Thank you. See, that's what I need. Those are good questions because you're looking at it going, that's not on my test. All right, so still did the same thing. This is good, bad. So it's not, XCP is 26. 26. Okay? And BAC is how much?
10.
10. So that means that this is 10 and this is 26. Better? Still understand how I got it then? Okay, good. All right. Sweet. Woo, that would have been bad because we're filming. So, thank you, Ezra. All right, so what do we do? And there's some easy things. This is an angle bisector, right? So that means, just think about it. If this whole thing's 10, then how much is each piece? If you cut 10 in half, what do you get? 5. Right? So that means this is 5 and this is 5. So now we know some very powerful things. We know that the measure of XAP is equal to 5, right? We know that the measure of ZAP is equal to 5, right? Okay. Now, if this is 26, how much is this? 26, right? If this half is 26 and the other half has to be 26, they're equal, right? Because it cut it in half. Does that make sense? It's an angle bisector. So both these have to be the same. So what's the total? What's 26 and 26? 50? Close? 50? 2. There you go. Okay? 52. It's 25 and 25 is 50, and 1 and 1 is 2. Right? 26 and 26, 52. Okay? So that whole piece. So I know a lot now. I know that the measure of angle ACB is equal to 52. I know that the measure of, I already knew that the measure of XCP was 26, so now I know the measure of YCP, right? Is 26. Okay? Why am I writing all of this down? Well, why not? They're going to ask me some questions. Why not get all the easy answers I can get out of the way? That's what I always think of. When I'm doing a test, I just bust out all the easy answers. Because you know they're going to come out with the hard one, right? And what's the hard one they're going to come at you with? Anyone give me a hard one. How do we do this? Definition of what? Angle bisector, right? We bisect an angle, we know it's cut in half. We know that if it's cut in half, they're equal. So the definition, whether it's the converse definition or the actual definition, we know that the half becomes a whole and the whole becomes half. Right? Okay. What do you think the question they're going to ask is the hard question? What's missing? Is there an angle missing? There's a lot of angles missing, but what's a big angle that's missing?